So we have the electric bass, which is consists of these 4 strings here. So we have the lowest string here, the thinnest string is G2. That's where we started from. Then we go up to D2, A1, and E1. The neck of the bass guitar is roughly 62.1 centimeters, 2.13, because that would be the largest calculation in our electric bass here, which is 24.459 inches. And we convert that to centimeters, it'd be 62.13 centimeters. So it's roughly the neck of the guitar from the nut to the back. The neck of the guitar, 62.13 centimeters. And the entire string length to the end of the bridge is 86.36 centimeters. So we're looking at basically this part here, all the strings have the same length, 86.36 all the way around from the nut to the back end of the bridge. And this would be like the, I don't know what they would call that fat part of the guitar. Is that the bell? Is it the bridge? You know, I think it's with the bridge is the consists of the 4 strings over the hole. I guess that's why they call it the bridge. It's the bridge over the hole. So yeah, so the bell, I was going to call it that. So the bell, the neck, and here's the front part of the guitar that we measure everything from. The head of the guitar and all that good stuff. Okay, so we'll start. That's our reference point. Nut to the back of the bridge, and that roughly comes out to be what is it? 34 inches for the electric bass from that standard. And so we have here. So this is basically our string length, which is the length of the guitar from the nuts to the bridge, which is 86.36, and this is a half of a wavelength. And then we want to find out what the full wavelength is, which is going to be twice the distance L, if we were looking for the entire wavelength, because this would be half of a wavelength. We know that a wavelength is consists of a crest and a trough, so top and bottom for a full wavelength, but that's just for side note. Okay, so the length of the string, 86.36. We have the speed of the string formula here, frequency times wavelength. And we know that the wavelength is going to be twice the distance L, F2L. So we have that there. And L naught signifies one of the quiz questions. One is the reference length of the string. It's basically this. L naught is 86.36. It's the string length. Okay, and then frequency 1, that would be the frequency of the string. So we look on our music sheet and we see that G2 resounds at roughly 98 hertz. And so we use that frequency in order to calculate the speed of the string. Once we get the speed of that string, we can get a placement of all the notes on the G2 string and the D2, the A1, and the E1. So we have the location of G sharp, because G is already taken care of because that is the string itself. So G sharp is going to be the velocity divided by 2 times the frequency of G sharp. We look on our music sheet. G sharp is roughly 103. Our standard is just going to use the first 3 sig figs, or the first digits before the decimal, to keep everything simple. We don't have to work with too many sig figs, although working with all the sig figs makes it more precise. But we'll keep things simpler. So velocity 169.3 divided by 2 times 103, and that becomes 206. So 169.3 divided by 206.8218. And then we get the difference between the reference length and the length or the location of G sharp. Keep it that way. Would be 86.36 minus 82.18, which is roughly 4.18 centimeters. That falls well within the first fret, because if we convert it properly, the first fret is 4.846 centimeters, so it falls in line. So it's good. If it was 4.86, we have a problem. So it falls out of the fret, but this one falls within, so we're good. And so we continue on. And like I said, on the Google Platform page, we're going to use 109, 54, 209, and 439 for the A frequencies. For some strange reason, like I said, like you can make that each fret, like for example, the 12th fret should be a little bit larger in order to accommodate for 110. It's probably really like 109.5, 109.8, something like that, and they rounded it up. You know, that's my speculation. But in order to keep things clean, we'll use just one below. So 109, 54, 219, and 439. So make that reference, make sure you have that from the main page. So it becomes out to be, so if I do this in terms of 109, right? So okay, so then this becomes 218. So 169.3, 77.66. And so this is just basically the physicist's job or the manufacturer's job in designing your bass guitar. And of course, the musician is, he should know how to play it. So we just want to create a nice enough bass guitar for the musician so that he can play well. So we have 77.66. That comes out to be 8.4 or 8.7. So that easily falls within the design. So before I go any further, I want to just write up the electric bass table. Make sure that we have all our conversions right. So I'm going to do that real fast, and then we'll come back to this. Okay, so for the electric bass, first fret from the nut to the end of the first fret is going to be 4.846 centimeters. I'm just going to do it in terms of 2 or 3 sig figs after the decimal. So try to do this as quickly as possible. Okay, so I'm not going to put the inches because we're going to convert from inches to centimeters. So these all in terms of the SI centimeters. Save a little time. Okay, so let me, so this is what you should have on paper just for your reference. So make sure that your fret calculations, the locations that you calculate are going to be falling within the frets. Okay, so they have to be less than these numbers. 4.846. The second fret should be 9.421. We just got 8.7, so that's easy. Falls right in there. So these are all centimeters. So instead of just writing centimeters all the time, $17.816. You should have gotten these from Tuesday. Okay, so 25.293. And I think too that when we do the 432, everything's going to fit, even when you use, well, actually it won't be no 440, it would be 432s and divisions of that. So the frets are going to, the distances that we have here, the standardized distances for these frets are going to easily accommodate the note locations in terms of 432 hertz. So that's, goes back to if you've ever heard anything about 432, a lot of people say it's, nice frequency for healing and all that good stuff. I mean, it very well could be, but we know at least it's a different, it's like a warmer, brighter, more relaxing tone for some musical compositions. Some people say that 432 kind of gets a little bad sounding when you're playing certain songs. I don't know. The jury's still out, I guess, on 432, but it seems to be a very nice tuning. All right, so 9th fret, 10th. 891. 40.612. The 12th fret, the infamous 12, 17 inches. Could probably make it 17.2, 17.3, whatever, stretch it out a little bit. And then at 440 or 220, it'll easily fit in there. But it's what it is. So 13. Um, 50.050. And 21. And the 22nd fret, 62.13 centimeters. So we got all 22. Those are our reference lengths. So those are all the fret distances from the nut to the 9th fret, 10th, and first all the way to 22. So that's going to be our reference points that we're going to use. So like when we get the locations of all the notes, they should fall before these numbers. So for example, first fret was 4.18, it falls before 4.846, fine. The second fret, 8.7, falls before 9.4. Now third and on up. So let's just do that as quickly as we can, I'll leave this up for another minute, but you should have all this on Tuesday. But let's see, everybody has that? Okay, you can write it or take a picture of it, sure. All right. Okay. Going on to the A sharp. So we continue up. So we start off at G2, and the question last time, what do we do after that? So we count all the notes upward. So G2, and then 22 notes above G2. So the first one would be G sharp, and then all the way up, you're gonna see that we wind so that we end up at F4, the F above middle C. Okay.
Kelly, I have a question.
Yeah.
Are the frequencies like the 198.3, is that the same for all strings or only for the G2 string?
U 198 or the 98 is
169.9.3. Sorry, 169.3.
no, that's the speed of G2. All the strings will have different speeds.
Oh shoot. Okay, that makes sense because I did the other strings with the same frequency and the numbers were all off.
Yeah.
That makes sense.
Okay.
What are they for the other
Well, we'll do those real quick. But yeah, we just have to calculate the different speeds. So G2 moves faster than D2 and so forth. So we'll calculate them. So all you have to do is just multiply 2 times the length of the string, 86.36 or 0.8636 times the frequency of that string in question. So we'll do that. So for example, for D2, you're going to be doing 2 times 0.8636 times 7341, 73.41. All right, well, let's just do that real fast. So to your question, so we have D2, we did G2 already. So the speed of D2 will be 2 L naught and the frequency of D2. And so we look on our sheet and D2 is 73.41. So the standard here, we'll just use 2 sigs after the decimal, just like we did for G2. And this speed will be 126.7 meters per second. So that's why it's different. It's not going to be 169. It's going to be this speed for D2. And then the A1 string. .8636. Then A1, 55 hertz. Although, you know, again, pretty good with that. Okay, so that becomes 94.99 meters per second. So this is why the speeds are different. For E, and then E1. Frequency for E1. That's 41.20. So see that? So not 169.3 for everything. Okay. So we were at note 3 for bass guitar, the A sharp. So we want to locate where A sharp is on our G2 3rd fret. Make sure it's inside the 3rd fret. A sharp 2. So like I said, all the other posted frequencies are fine. There's some peculiarity with A. 232. 266. And so then we do the delta X, which is the difference between the string length and the location length, if you will. So that will be L naught, 86.36 minus this in centimeters, 72.66 equals 13.7 centimeters. And so we are well within the third fret, easily, 13.7. And we know that the distance of the third fret is 13.74. Okay, so
Mr. Kelly,
yes.
it's okay for like mine because mine was 13.6 centimeters. So is that's fine as well?
Yeah, that's fine.
Okay, because I wasn't sure if you wanted like a specific number.
No, as long as it's
stays.
Yeah, as long as
in
it's
the fret.
after, right, as long as it's after
Yeah.
9.4 and before it's 13.74.
Okay, thank you.
Yeah. So these are going to tend towards the end of the frets, as far as the greatest sound quality. That's why all your numbers are going to be towards the end of the fret, mostly. Okay. Yeah, that's depends on the sig figs that you use too. So 13.6 is fine. So B2, same thing. So 2. And all right, so let's leave this here. 246. So 17.6, and the fourth fret is 17.8. So fine. So when getting all these numbers, what I'd like you to do is like make a chart of the notes and their lengths. So I'll do an example of that down the line, but this is what we want to have first. It's like the calculations. Okay, so that's 17.6 centimeters. All right, so let's speed this up here. When you do that, you're going to get 21.25, and the fifth fret is 21.66, so good. Hovik, off the phone. We should be copying these things down. 169.3. Very simple because we're doing this together. So next up, 134. 25.02. 25.293. So working out. The location of the D3, third octave. Very bass. Comes out to be 5797. in terms of centimeters. So 7th fret, 28.72, it's 28.39, good. E sharp. Should have brought my trumpet here and just played the trumpet equivalents. These notes. Okay, so in 155.5, we're going to use, of course, just the base number 155. $31.75. And again, sig figs, you know, 31.7, 31.6. It's all good. This was 31.955, so good. So then this is going to be the pattern, because when we do the electric guitar, same pattern. We're going to get the fret distances, get the speed of each string. In that case, it's going to be 6 strings for the electric guitar, sometimes 7, 6 strings. Right, and then get the speeds, and then we get the locations of each of the notes. Just as we're doing here. All right. So E3, 164. It's going to be 5161. $34.75. That's 9th is 35.08, so this is fine. And the infamous 12th fret. Came first, the tuning in A or the fret calculations. Okay. 64. $37.72. So that's fine. 37.81, 891. This is 184. Okay, so everybody's good. Hanging in there. Okay, so 40.36 for the 11th fret and the distance 40.6. Very fine. So now on the 12th fret, that was the issue before. Well, actually, no, just where the A was. You know, some strings have the A at the 12th fret, but no, G3 now. Velocity over twice the frequency of this note, which is 195. Okay, so 43.18, and that's the extent of the fret, 43.18, and we get 42.95. Good. G sharp. You all should get this pattern by now. 45.47. So 4. Okay, and then 45.603, 45.47. Fall in line. Fall in there. Now the infamous A note. Where we do 219. Probably like 219.5, 219.8. They rounded it up. Speculation. This is 38.65. Sure of that. Yep. $47.71 and 14th 47.89. All good there. So A sharp 3. So that's 36.33. $50.03. Just fill in there. 50.05, 50.03. Good. Okay. That's 51.95. Good. We should be good on the way home here. So middle C now. $261. We'll see that on the 432 hertz is 256. You may have heard that the most tuning forks, or at least some tuning forks, come in at 256. That's based on the 432 scale. So $32.43. $53.93 centimeters. Okay. So far, so good. Good. All right. And 1754.011. All right. C sharp. $3.56. $55.8. For messing around, you can say 55.80, doesn't matter. That falls within the 18th fret, 55.82, 55.80. Location of D4. $57.47. All right, and that's 57.5, the extent of the 19th fret. It's 27, 21. $9.15. That was cutting it close, but at 59.159, our sig figs, you get 59.15 right in there. So 20 is good. Then 21, the E4. $25.72. $60.64. The extent of 21 is 60.68. Good. And lastly, 22. Second fret. $24.25. 62.11. That's it. You should all have that. Everything fits in. Using the standard for A, 119. What did we do? We did 219. And then when we get to 110, it'd be 109, just one less for the A. So that would be the pattern for the next string up, which is the D2 string. We just calculated the velocities for all the rest of the strings. So we can see here, D2, 126.7, A1, 94.99, and E1, 71.16, and do the same logic. Okay, so for D2, 126.7, first one, we locate the position of D sharp 2 for E flat, same thing. And then so on. Any questions? I need to see anything else. So why don't you do the rest of these? I mean, do the rest. It's going to be yeah. This should. I don't understand why there's any lag, but let's go ahead and do the rest of the strings. Let's see how far we can get. Should be close to being done. Okay. Okay. Like I said, for D2, just did this speed here. Velocity is twice the wavelength times the frequency of the D2 string. 2 times the reference length, 0.8636, and the D2 frequency, 73.41 hertz, 126.7 meters per second. So now the first note on the D2 string would be D sharp 2 or E flat. And so we're trying to figure out the location of D sharp on the D2 string, 126.7 divided by 2 times 77. We're going to use the digits before the decimal. And that becomes 8227. Roughly 4.09. Now, if you were being very precise using all the sig figs, they should literally be at the same locations for all the strings. We're just not being that precise for time purposes. We're being precise enough so that we can fall within the frets. So, like for example, like G2, the first note was 4.18. This is 4.09. It means like semantics. 0.09 centimeters is nothing. We fall in the fret, so that's the point. So you do that for D2 and A1. Same. Take the speeds, location. Does anybody need me to do the first one for A1 and E1? It's the same thing as this. So how much we can get done, because given everything that we're doing, everything being equal, we're going to take 2 weeks to do the electric guitar. Right? So we have to, that's 6 strings. And if you guys are lagging on 4, we need extra time. And then our last bit of this project, we're going to, like I said, we're going to recreate this whole music chart in terms of 432 hertz. That should be quite fun. Hope you find that fun. So that being said, let's have this bass guitar done by Monday. All the strings. Okay. The calculations for all the strings for and a table. I was on I have it on my phone. My phone is dead. Get some life in this. Okay, so I want the calculations on a chart.